Okay, so theorem time. So if a sequence AN is both bounded and monotonic, then it will mean that sequence will definitely converge. So remember bounded means a sequence being trapped within the upper bound capital M and the lower bound small m. So remember bounded means a sequence being trapped within a tunnel. It cannot go beyond the ceiling and it cannot go below the floor. It's always being trapped. Well, it's always what bounded means is trapped within a tunnel. So if a sequence is bounded, meaning it's trapped within a tunnel, and it's monotonic, you see this sequence here, this sequence here is bounded, but it is not monotonic. Remember, monotonic means a sequence keeps. Well, monotonic means the next sequence an plus 1 is always greater or equal to an. So you can interpret monotonic as a sequence always climbing, or it could be equal to. So or it could be this, a straight line like this. So this here is monotonic. This here is also monotonic. And by the way, if it's going downhill all the time, then it's also monotonic. So monotonic. Remember, monotonic means it could be non-decreasing, so it could be non-decreasing, or it could be non-increasing. So this here is monotonic. If it's climbing all the time, then it's monotonic. If it stays the same, then it's monotonic. If it's going downhill all the time, then it's monotonic. Well, if a sequence is bounded and monotonic, then it must mean it must converge because of this. Let's say it's bounded. It's bounded, so it's trapped within the upper bound and the lower bound. Well, if it's monotonic, remember monotonic means it's either climb. Well, let's just say in the case of it's always climbing. If it's always climbing and it cannot go beyond the ceiling, then it must converge. So here, if it's always climbing, then it must converge. It cannot go beyond the ceiling, so it must converge. If you have a sequence like this, let's say it's trapped within this tunnel, so it is bounded. If it's going downhill all the time, if it's going downhill, if it's going downhill all the time, then it must. If it's going downhill all the time and it's bounded, then it must converge to a limit. It must converge. Well, here in this case, it's converging here. And by the way, this here could be a plausible scenario here. So you've got a sequence that is bounded, and then if a sequence is just a straight line here, remember a straight line. If you have a sequence that's like an plus 1 is equal to an all the time, meaning it's a straight line, then it is satisfying this. The sequence is converging. It is converging. Well, it has a limit if it's just a straight line. And also this here is also plausible. If the sequence is trapped within a tunnel, if it's always decreasing here, if it's always decreasing, it's decreasing, but then it stays the same all the time. Then if it's staying all the time, then it's still converging. It has a limit. So this theorem will always be true. If it is both, remember it has to be both bounded and monotonic, then it will mean that the sequence must converge. No matter what you do, if it's monotonic and bounded, then it must converge. Okay?